Hi everyone. Starting from this video, we are going to do chapter 3, polynomials and expressions. This is the first video. We are going to have 7 videos for this chapter. So let's look at today's objectives. We have 3. First, we want to be able to tell the difference between an expression and an equation. And then we want to be able to translate a word phrase to an expression. And the last one that we want to be able to learn how to evaluate a given expression. Okay, let's get started. First, what is an expression? An expression could be a constant number, could be a variable, or any combinations between variables and constants using mathematical operators. And a mathematical operator doesn't have to be plus, minus, multiply, divide in arithmetics. It could be other operations. So what is an equation then? Apparently, equation means something equals something else, right? So you're going to see a equal sign in the equation. So the major difference is that an expression doesn't have an equal sign. An equation will have equal sign in it. So let's look at our first example. Determine whether each of the following is an expression or an equation and give explanations. First, A, 16 times 5 equals 80. So we have equal sign. This is an equation. Specifically, this is the numeric equation because we don't have variable or variables in it. We just have numbers. So we call it numeric equation. Now, our second example and the third one also. Let's focus on the second one. And this is an equation. We have equal sign in it. And we also have variables in it. So as a result, this is called algebraic equation. You can just say it is equation because it is. But specifically, if you want to differentiate between numeric equation or algebraic equation, this is an algebraic equation because we have variables in it. Now the third one, C, I times R. And we don't have an equal sign in it, so this is an expression. Since we have variables actually in it, we call it algebraic expression. I think by this point, you are very clear about the difference between equation and expression. Now, this is your first exercise set. And all of the answers to the exercise questions are in the comment area below the video. So let's look at our next topic. We want to know how to translate word phrases to expressions. And why do we want to translate word phrases into expressions? Because in mathematics, before we can solve real-life problems, we have to represent those problems in a mathematical way. So that's why we want to learn how to translate word phrases into expressions and correctly, accurately. And first, why do we even have variables in algebra? And this is a fundamental difference between algebra and arithmetics. In arithmetics, we just do basic calculations using numbers. For example, we can add, we can subtract, multiply, divide between two numbers or among multiple numbers. We only work with numbers. But why do we need variables in algebra because sometimes we don't know the numbers for something. For example, we want to add the length and width of a table together, but for the moment, we don't know those two numbers. In arithmetic, you cannot do anything about it because you don't know those two numbers. But in algebra, we just use two variables to represent those two specific values. We call it length and width. We can still add them together even though we don't know the values for those two measurements. That's fundamental difference, and that makes algebra super powerful. Okay, now let's look at some basic translations, and this is our foundation to be able to translate a more complex phrases to a mathematical expression. So let's look at this basic translations on the next page. So we have several tables here. Let's look at them one by one. On the left, this basic translation is about addition. So how do you know you should add the two numbers together? First, the indication is the word sum of x and 3. Sum of something, and you need to add them together, right? So x plus 3. Also, plus indicates addition. H plus k. So we write it as in mathematics h plus k using this addition operator, right? T added to 7. So you have 7, you add t to it. That's why you put 7 first, then plus t. Even though there's no difference in terms of order of those two numbers when you do addition, 3 plus 4 equals 4 plus 3, right? We want to make sure people understand this description. You have 7 come first, then you add t to it. Now, 3 more than some number. So this is why we need a variable in algebra. We don't know what that number is, but we still can add 3 to it. So you have to have that number first, then add 3 to it. For example, if this some number becomes, say, 5, it would be read as 3 more than 5. You know, that's 8. 5 plus 3, right? N can be any number. That's why we use a variable in algebra. Now, the last one, y increased by 2. So you have to have y first before you can increase it by any amount, right? That's why they write this as y plus 2, even though, again, 2 plus y is also correct because the order doesn't make any difference. We have commutative property of addition. Now, second table is about subtraction. The key word is difference. The difference of 3 and x. So we know that there's no commutative property in subtraction. So it's critical to know which number is the first number and which number is the second number in your subtraction. Basically, it goes like this. In the description of subtraction, whichever number comes first should be your first number in your mathematical expression. Say the difference of 3 and x, 3 goes first, 3 minus x. H minus k, this is straightforward. 7 subtracted from t. So t has to be the first number before you can subtract something from it. That's why we put t as a first number. Very similar here, 3 less than the number. You have to have a number first before you can have a number less than that. So that's why that number n, we use n to represent that number, n minus 3. You see, they use different variables. You can use any variable you want. Last one, decreased by y. So you have to have 2 first before you can decrease it by any amount. That's why we translated to 2 minus y. Now let's look at other operations. Now the next one is multiplication on the left side. And the keyword to indicate multiplication is product, because product is a result of multiplication. So this one says the product of 3 and x. We also know that there's a commutative property for multiplication. That means order doesn't matter in multiplication results. Say 2 times 3 equals 3 times 2, right? But that being said, in algebra, whenever you have multiplication between numbers and variables, you always put numbers in front of variables, and that's just convention. So the product of 3 and x, that's 3x, is 3 times x. So in algebra, if there's nothing in between, it really means multiplication. Okay, the next one, h times k. Again, this is straightforward. Some number multiplied by 5. Multiply, straightforward indication is multiplication. So some number, we use a variable n to represent that, multiply by 5. Again, we put number in front of variable in multiplication. Twice a number. So double a number, you have to multiply by 2 to double a number, right? That's why it's multiplication. As the same goes with triple. So triple number, you have to multiply that number by 3. Now let's look at the table on the right side, which is for division. Addition is pretty much like subtraction, order matters. 10 divided by 2 is not the same as 2 divided by 10, right? So we just pay attention to which number should be the first in the division, which one should be the second. The quotient is a keyword for division operation. The quotient of x and 3, this goes the same as in subtraction. Whichever comes first should be your first number in your division, or the top number if you write your division in fraction format, because in fraction, this bar is also called division bar. So quotient of x and 3 is x divided by 3. Now, another one, h divided by k. This is pretty straightforward. Divided by, this k has to be the second number. So h divided by k. H on the top, k on the bottom. And the last one, h divided into k. This is a subtle difference, but it's a fundamental difference. Whenever you use something divided into something, this item, this number, or this variable should be the first one or the top one. So k divided by h, or k divided by h in fraction format. For example, 5 divided into 10, that means you get 2. That's 10 divided by 5. Okay, we have a little bit more on these basic translations. The next one on the left side is for exponential operations, and they call it exponent. And it is actually an operation just like multiplication, addition, division, subtraction, right? So this is an exponential operation. An exponential operation really means something multiplied by itself this many times. So if I use this, say, a to the n, this is a general format when we write an exponential operation. A is called base. It can be a number, can be a variable. And n is called exponent. So let's do this quick review. And the base is the number that you want to multiply by itself. N is called exponent, which indicates how many times you're going to multiply this base by itself. So let's look at our examples here. C squared. Squared means twice, so that's the exponent. Then C is the base. You're going to multiply this C by itself twice. That's why we write it this way. C is the base, then 2 is the exponent. The square of b, the same thing, square and a cube, and indicate this exponent, and this is a base. So b squared, square of b squared, the same thing. K cubed, pretty much like a b squared. Instead of having 2 as the exponent, you have 3 as the exponent. We call it cube, because cube really has all 3 sides equal in length, like length, width, and height, right? That's a cube. That's why we call it a cube, 3 dimensions. Now, n to the 4th power. Power, nth power can be any order of power. It's another way to say exponential operation. This indication of being exponent. So you have 4 as exponent, n is the base. So n to the power of 4. And we can also read this one as n to the 4th power, n to the power of 4, or n raised to the power of 4, something like that. Yeah, pretty much like this next one. Y raised to the 5th power. So the 5th power is the exponent, which is 5. Y is the base. The last one is a square root, and this is straightforward. Square root of x. Square root has a symbol pretty much like division symbol, and this is a operand you're going to operate this square root on. So you put it inside. Square root is a number that when you multiply it by itself, the result will be the given number. For example, square root of 16 is 4. So when 4 multiplied by itself is equal to the given number. That's called a square root. Okay, let's move on to our next slide. Now, when we translate these keywords such as the sum, the difference, the product, the quotient, and it's an operation between 2 numbers, and usually they are separated by and. So in other words, and, the word and can be served as indicator of the 2 parts. You have a part before and, you have the part after and. This is some illustrations here. Sum of x and 3, that's why you add these 2 parts together, separated by and. Same thing for the subtraction, x and 3, x minus 3. Product between x and 3 and x times 3. Again, you can write it as 3 times x. We usually write the number in front of variable in multiplication. And quotient of x and 3. So that's division between these 2 numbers. We put x first because x comes first in division. So the order matters. So x divided by 3. Now let's look at our second example. Now we're going to practice translating phrases into expressions. 7 added to the product of 4 and x. So 7 added to something, we know that we're going to add that something by 7, add 7 to it. So we have to have this thing first, whatever it is, before we can add 7 to it to make sense, right? But this thing is the product of 4 and x. So we need to multiply 4 and x. That's product of 4 and x. Then we add 7 to it. 7 is added to it. So we add 7 to it. So basically, when we translate a phrase to an expression, we translate it in terms of the meaning. So that's why we need to read it to understand the meaning before we translate it. And this translation is super important because it represents the original information in the description. If your translation is wrong, the subsequent operations, whatever you do, is already wrong. It's basically meaningless. Now, second one, 10 subtracted from the quotient of some other number and the 3. And this one has a very similar structure as in the first one. 7 added to something, 10 subtracted from something. In either case, you have to have this something first, whatever it is. Later on, we look at the detail. The basic structure is that 10 is subtracted from this thing. So we have to have that thing first. And this thing is division between some number and 3. So some number has to be the first number in the division. Now let's use n. We can use any variable we want. This time, let's use n to represent the some number and 3. Quotient of some number and 3. And then 10 is subtracted from this quotient. The result of division is called quotient. Yeah, that's our representation. That is our translation. The next one, 12 less than the square of some number. Again, you have to have this number first before you can figure out what is the number that is 12 less than that, right? Like 12 less than 20, you know, that's 8. But before you have 20, there's no way you can find out the 8, right? So you have to have this number first. This is a square of some number. That is our variable. Let's use n again. Square of n. And 12 less than that. So take 12 away from it. So that's the translation. Now the next one, 9 divided into the square root of some number. Still remember, divide into is equivalent to say 5 divided into 10. And this part comes first. And this part is the square root of some number. This time let's use a different variable for a change. Let's use x to represent that some number. Square root of some number, 9 divided into that. So that's the translation. Now, this is your second set of exercise questions. Now let's move on to our next learning objective. We want to translate phrases involving parentheses. And the very reason we have parentheses in the mathematical expression is because of the order of operations. So let's look at our first example. 4 times the sum of y and 5. Say if I write this reading, I'm going to write what I read from left to the right. It would be this. 4 times the sum means addition, the sum of y and 5. So without parentheses, it would indicate, this expression indicates that it is a sum between 4y and 5. Because we have, according to the order of operations, we have to do multiplication first before we can do sum. So this expression essentially means this is a sum between 4y and 5. It's not the original meaning of sum between y and 5. That's why we need parentheses. Because 4 times the sum, which is the result of addition. Without result of addition, you cannot multiply it by 4. That's why we have to do addition first. But addition has lower priority in terms of order of operations. In order to indicate we need to do addition before we do multiplication in this expression, we have to make this addition a priority. Higher priority over multiplication. How do we do that? Parentheses. Because in terms of the order of operations, the operations inside parentheses has higher priority than multiplication division. That's why we use parentheses to force it that we need to do addition first, so that this one will follow the requirement of this description, so that we can represent the description accurately. Okay, now next one. The product of -6 and the difference of some number and 2. So the basic structure is that we're looking for the product of something. Product is between two parts. This is our first part. A second part is separated by and. So we learned that before, right? Anything after the and is the second part. So you're going to multiply this -6 with the second part. So what is second part? Second part is difference between two numbers. So we have to get the difference before we can multiply. That's the indication you need parentheses, because subtraction has lower priority without parentheses. But we have to do the subtraction first to get the difference before we can multiply. So that's why we have parentheses. The first number is some number we don't know. We use x to represent that. A second number in subtraction is 2. So that's our representation. The third example, let's translate this one. The sum of x squared. So sum is between two parts. First part is x squared. Second part is separated by and. This is the second part, whatever it is. So x squared, everybody can translate that. And the sum between x squared and this thing. Now let's translate this part. 3 divided by the difference of y and 4. So this is division between two parts, right? 3 divided by, so 3 is on the top. And the part on the bottom is the difference of y and 4. Difference indicates subtraction, y and 4. So that's our final answer. Oh, I made a mistake, I think. So now the mistake is this. The major structure is that this sum is divided by the difference. So I take this back, say this is a perfect example to demonstrate that everybody could make mistake, right? So this sum is divided by the difference. So let me correct myself. X squared and 3. This sum is divided by the difference between y and 4. This is the correct answer. So this happened occasionally. It's in the video for sure, but also in my teaching, even though I have been teaching different levels of mathematics for 20 years. Okay, let's move on. The third set of exercise questions. You have 3 also. And let's look at our next topic. We want to learn how to evaluate an expression. So basically, there are 2 things we can do to an expression. Either we simplify it to make it simplest form, and or we can evaluate it. So this part, we are looking at how to evaluate a given expression. So general process is that all you need to do is replace the variables in a given expression with specific values. And then you calculate result. So the final answer should be a single number. So let's do some examples. The first one, number A. Say we are given this expression x squared plus 5x minus 7, and we evaluate this expression for x equals -3. So we need to replace every single x occurrence with -3. So it is best practice when you do evaluation that you use parentheses to surround the given value. For example, this one. So x is -3. And 5 times -3 minus 7. Without parentheses, -3 squared really means -1 times 3 squared, which is -9. With parentheses, it really means the base multiplied by itself, that is -3 times -3, it is +9. Huge difference. So this is just a best practice. Okay. And another best practice is that don't try to figure out the answer just by looking at this and do your calculation in your head. And you want to plug in this given numbers if you have more than one variable, and then do the calculation. The reason is very simple. And when you have more complex expression to evaluate, nobody can do this calculation accurately all the time mentally. Okay, so this is a +9, this is -15 plus -15, and then -7. Usually in mathematics, we want to write things in a simpler way. Whenever you have two symbols in the row, we can always simplify it so that we have one operation. So plus minus equals just minus itself. So this becomes 9 minus 15 minus 7. 9 minus 15 is -6 minus 7, and this is -13. So you can do the subtraction with negative numbers really fast if you just look at all of these numbers, no matter plus minus, individually. So if you look at it individually, you read the whatever in front of number as a sign, not an operator. So to me, it goes like this: -6, -7. These two numbers both are negative. They go in the same direction. They accumulate. It's getting bigger in that direction. That is -13. Once you get used to it, this way of thinking, you can do all of these subtractions, additions with negative numbers super fast. Okay, our second evaluation question. We have two variables now. As in the previous one, we just plug in numbers first. So -x, x itself is -3. Plus 5, x is -3, and y is 1. Yeah, that's the whole thing. So we just simplify it. Negative equal to positive. And we do operations inside the parentheses first, which gives us -2. So when you add two numbers with different signs, the one with the smaller size get canceled, and you get leftover from the one with bigger size. So 3 is bigger than 1 in terms of magnitude. So we have leftover from 3, which is 2. And since leftover is from negative number, it's still negative. Now we do this multiplication first. So 3 plus -10. Now this time, 3 get canceled. You got -7 left. Yeah, I guess we have more examples. Practice is important in learning mathematics, especially when you learn basic skills. Enough exercise will benefit you for the long run. Now let's look at our next one. So R is -2. This is the absolute value bars. So I got -2 square minus p. P itself is 6 plus 4 times r. And that's it. Let's do the calculation. -2 square is +4 plus -8. And 4 minus 6 is -2. Make sure you do the operation inside absolute value bars first. Absolute value bars in terms of order of operations is pretty much like parentheses. You do all of the operations inside before you take the absolute value. And plus -8. Absolute value of -2 is +2 plus -8. And 2 get canceled, we get left over from -8, which is -6. We have another one. And square root of m plus n and plus m times n. We get given m n values, so we plug in 7 times square root of -6 and plus n plus 10. Outside the square root, we have m times n. So first step, plug in numbers, and then we do the calculation. Square root inside -6 plus 10, that's +4. Then this multiplication, we can do this at the same time because it has priority higher than addition. We can do this first. And that's -60. Now square root of 4 is 2. And plus -60. Do multiplication first. 14 plus -60. And 14 get canceled. And the leftover is 60, it is 46. So -46. The last example for this video, we have a fraction. H equals 2, K equals -5. On the top, 3 times H square, 2 square. On the bottom, K plus 5. K is -5 and plus 5. So on the top, we have 3 times, we do exponential operations first. That is 4. On the bottom is 0. So we get 12 divided by 0. And you cannot divide by 0. So we call this undefined. We don't say it has no solution because this is not equation. We are not looking for any number. We just evaluate this expression. So there's no result. So we call it undefined. Now, this is the next page is your last set of exercise questions. You have plenty. Again, enough exercise is essential and necessary in learning mathematics, especially basic skills. That's all for this one. See you in the next video.